Hello and welcome back. In this video we're going to be covering piecewise functions and everything you need to know about the quadratic formula. As always, if you find it helpful and want to help the channel, leave a like, subscribe to see when I post more videos or help others find the channel, and comment with any questions you might have or things that you like. But let's get right to it. We're going to start with the piecewise functions, beginning with what is a piecewise function? Now this might sound familiar if you watch all my other videos because I gave a quick hint and primer for this in the number lines video actually, so we'll get a reminder from that here on the next slide. But a piecewise function is just any function or graph that actually consists of multiple equations in different regions of x values. So it'll be one equation or formula for, let's say, the left portion, and then it'll suddenly switch at a certain x point, and now it's a new function, and it could switch who knows how many times. Normally you're only going to see 2 or 3 though on something like the ACT. So what are you going to have to do with these kind of graphs? One, you might just have to read the y value of a function if given x. So they'll give you the graph and just tell you at x, what is y? That's the most common one. It's not that hard. You just have to know a few little tricks because this is actually one of the most commonly missed types of questions. Or they might have you match a graph to its equation or set of equations, depending on how you want to look at it. This one's not as common, but it's still tested. So, as I said, we actually did talk about this a little bit in number lines, so here's a quick reminder. If you see a hollow dot, so something like this right here, that means that the point on the dot, so like this example here, that's the -3, that is not included. So if someone asked, hey, is -3 part of this function? The answer would be no, because it's hollow. Whereas if it's solid, like you see here or here, that means or equal to, then that means that point of the dot is included. So 1 in these two cases would be included. So let's take a look at this example. This is a type of step function, which is actually one of the most commonly tested on the ACT, where it's just a horizontal line, then it switches, it's another horizontal line. It might keep switching. I've even seen ones where it just goes up 1, then it goes over a bit, then it goes up 1, over a bit, up 1, over again, and it keeps going. But on these graphs, there's a few things you need to know, and then I'll get to this part in a second. They're almost never going to ask, okay, what's x over here? Because then it's just reading a line. Almost always they will test at the point where it switches. So these switching points are very important. And notice you're always going to find one hollow dot at these and one solid. If we remember from the previous slide, hollow is not included. So at x equals 2, you would go up. This is going to be the first line you get to, but because this is hollow, this is not part of the function. That is technically at x is less than 2. So at 2, because it's not less than or equal to, this one doesn't count. That's what this here is. You have to go up here to the solid dot, that's the or equal to 2, and your answer is 4. So that's really the most important thing, is knowing the difference between the hollow and the solid dots. Now, as far as how do I read these functions and how are they written, you're always going to see something like this. There's a few different ways that it might look, but you're going to see y equals or f of x equals, then a bracket, and then they're just going to have a list of all of the different equations. In this case, because they're just horizontal lines, each formula is just a number. But they could be entire equations, which I'll give you an example in the next slide of that. And then to the right of that, they're going to give for what range is the function going to be this formula. You might see if x equals or if given a range of x. You also might see just the x range in parentheses next to it. There's different ways of writing it, but it's going to look very similar each time. So in this one, there are two different equations that y follows. If x is less than 2, not or equal to, but less than 2, then y is 1. And then at 2, it switches and becomes 4 at greater than or equal to 2. So at 2 it is 4, and anything greater than 2, y will be 4. So, as I had said earlier, the question you're going to get on the ACT if you see this is, what is y at x equals 2? Now remember what we pointed out is it exists at both places at 2, or at least these lines do. But this one is not included at y equals 1 because it's a hollow dot. You need the solid dot, so y is 4. So here's an example of a more complicated function. In this case I have 3 different equations that we're bouncing between. And here we have the same, y equals with a bracket, and then here's all 3. From left to right, we have x squared. That's this red one, so notice the parabola. At x is less than or equal to negative 1. That or equal to is important because that tells me we need a solid dot here. Then we have y equals x, so just a regular old line with a positive slope of 1. At negative 1 is less than x. Notice there's no or equal to, so that's the hollow dot. And x is less than or equal to, so I have a solid dot, 2. And finally, this green one here, y equals negative x plus 10. That's why I just have a regular old line with a negative slope at x is greater than 2. So notice it's greater than, so this is going to be hollow, not solid, because there's no or equal to. So if they do decide to ask you what's the value of y at some point, they're almost always going to ask about these points where the functions shift. So if they ask at negative 1, x equals negative 1, is y going to be negative 1 or positive 1? Remember, we do not include the hollow dot, so we need the solid, so your answer is going to be 1. Likewise, at x equals 2, if they ask about that one, you're going to have both of these answer choices, 2 or 8. This one's hollow, this one's solid, so that's what we need. The answer is 2. So again, let's look at this and talk about the other type of question they might ask, because we've only dealt so far with at x equals this, what is y? The other thing they might do is give you this, and then give you 4 or 5, depending on when you're taking the test, different graph options and ask which one is this. Or maybe they give you the graph and ask you which of these is it. I haven't ever seen them do that. If they do, it would generally be very simple formulas. But to do these matches, there's a few things you have to check. So first, general shape of these graphs. So notice this is a parabola, so that one has to be x squared. And these two are lines. So that's a quick way you can check. If they had part of a parabola over here at the greater than 2 part, that's not a parabola equation. I can get rid of that option. So those are the kinds you can think about. You can also look at the slope, because notice both of these are lines, which are pretty simple, whereas this one has a positive slope, this one has a negative. So if this one was going down in this region and then up over here, then that would be the wrong answer. So that's a quick and easy check, but depending on how comfortable you are with the different graph shapes, you can quickly eliminate with this, or if you're less comfortable with it, you can check that part last if you have to. Other things you can look at, the x values, where the shape changes. So, notice I didn't say y yet, that's going to be later. But first, just easy as that is, it says right here, changes at x is negative 1. So is this shift happening at negative 1? Yeah. If there was a graph where that shift happened at negative 2, that's the wrong one. Then the next step obviously would be, what about the y value at these? So plug in negative 1 into both of these two where it shifts, and that will tell you which of these 2 points you have to have. Then double check the solid versus hollow. Once you've plugged in at that to make sure that, okay, we're at the right point. So let's say this one was up here at 2, that would be wrong. So wrong y value, that one's out. But there was probably going to be 2 options where the y is correctly here and here. But one of them, it's going to be solid in both places. Another will have hollow here and solid here, and then the other will have it correct. So double check anywhere you see or equal to. That one needs to be solid, where if you don't have or equal to, it needs to be hollow. And that's really all that matters to be able to pick the right graph or the right formula and match them back and forth. So then that brings us to the quadratic formula. Now admittedly, this one is not generally tested that frequently, but it is occasionally, and the math test is always changing. So they might end up testing it more or less in the future. I want to make sure that it's here. There's a few things that we're going to need to know here, so I do want to go through them with you. The first would just be solving a quadratic equation using the quadratic formula. A more complicated thing that you're going to possibly see is the question of how many solutions are going to exist for this formula. Or they might say, hey, this is a parabola. How many times will it cross the x-axis? Or how many x-intercepts will there be? These are all related to the quadratic formula. So, let's go and figure out, how do we solve these things? What is the quadratic formula? Well, they're going to solve a quadratic equation. So this isn't the quadratic formula, this is just the type of equation you would solve with the quadratic formula. So it's y equals ax squared plus bx plus c, with a, b, and c being any constant. So, important thing to note here, if we're going to do the quadratic formula, we have to have this exact form. So, y off by itself, no number in front of it, no y squared, just y. And then everything else on the other side of the equation. If there is no y, so if they just gave you ax squared plus bx plus c and asked, what's the x-intercept or x-intercepts, or what's the solution to these, then you need to set it equal to 0. So do whatever math you need to have 0 on one side of the equation, or y, and then everything else on the other. Once it's in that format, then that's how we know the solutions, when they ask about those, are the x values, where y equals 0. That's why we need y by itself, and we just set it equal to 0. Those are the x-intercepts. The only reason I'm pointing that out is they might ask for the same thing, but in several different ways. They might ask, what's the solution? What are the x-intercepts? It's the same thing. So to solve it, we're going to use this, the quadratic formula. This is one of the few formulas which you will have to have memorized, because they will not give it to you if they do test it. Maybe that changes, but I have not seen them give it to you. So it is x, that's your solution, equals negative b, that's the number in front of the plane x with no exponent, plus or minus the square root of b squared minus 4ac, with a being the value in front of x squared, and c being the thing with no x. Excuse me. So, all of that then is over to a. Now do keep in mind, if you don't see a number in front of any of these, or if there is no number without anything in front that's missing, that's going to be a 1, and if there's no plus anything, c will be 0. Now do keep in mind here, there's a plus minus, so we actually end up with potentially 2 answers, because if we add, we're going to get one answer. If we subtract, we get the other answer. Now I'll come back to that in a bit. So, another little tip here is that if you have a graphing calculator, as long as that's allowed in the ACT, always double check that you have the correct type of calculator. You can also just use your calculator to solve these most of the time. And I will show you how to do that on the last slide here today, but I want to show you how to do this properly, because there's another type of question that they might just give you variables and ask generically about it. And there's no way to use your calculator for that. You have to understand this formula and what it means. So I'll start with that. So let's just solve an example here. Y equals x squared plus 3x plus 2. And we're going to use the quadratic formula. So a is going to be 1, because there's nothing in front of the x. B is 3, and c is 2. So again, here's my formula. And here it is when you plug it in. So I know there's a lot of stuff. Let's walk through it kind of quickly. But feel free to pause and walk through it yourself. Make sure you understand the math I was doing. So I plugged 3 in everywhere that I see b. That's here and here. I plugged 1 in where I see a, here and here. And the only c, the 2, goes right here. So that's how you ended up with this part. Then I just went ahead, 2 times 1, that's 2. And I solved this. 3 squared is 9, minus 4 times 2 times 1 is 8. So 9 minus 8 is 1. That's how I ended up here. So square root of 1, that's still just 1. So now I have this. And that's at this point, I can do the plus minus. So I start with the minus in this case. You can do it whatever you want. Negative 3 minus 1 is negative 4. And the over 2 is still there. If I did the add, minus 3 plus 1 gives me negative 2. Over 2 still. So then that gives me negative 2 or negative 1. Those are both solutions to this, and that would be your answer. Now, notice the value under the radical, so under the square root. This all came out to be 1, which is a positive number. That is important that I'm going to go talk about now on the next slide. Alright, so now let's talk about what I was just hinting at. The part under the square root, the b squared minus 4ac. That is all I care about if they ask me, how many solutions are there? How many times does it cross the x-axis? Or how many x-intercepts are there? Anything along those lines. That's the only part that matters to tell me if I'm going to have 2 solutions, 1 solution, or no solutions. So let's go through all 3 situations and explain why that is to help you be able to figure that out and remember it. So let's start with the most common, and that's where b squared minus 4ac, when you plug all that in, gives me something greater than 0. So it's going to be a positive number. And those are the 3 situations, by the way. Just a quick hint. Positive, you're going to have 2. Negative, you're going to have 0. If you just get 0, you're going to have 1 solution. So let's go into that. if b squared minus 4ac gives me a positive number, there's going to be two solutions or two x-intercepts. Why is that? Well, when you have the square root of a positive number, you're going to get a positive number. So when I go and plug this in to that top part of the quadratic formula, I'm going to have negative b plus a number. That's one answer. Then negative b minus a number is going to end up giving me another number, because that plus minus is going to have to give me two different answers. And that's fine. That's how we end up with two solutions if I have a positive number. Well, then what happens then if I plug in b squared minus 4ac and end up with 0? So let's say this gave me 9, and then somehow this also gave me 9. 9 minus 9 gives me 0. That could happen. If that does happen, there's going to be one solution, or one x-intercept. That would be like a parabola that just comes down and touches the x-axis without crossing it. The vertex would be at x equals 0. Why does that happen when you have equals 0? Because when you plug in the square root of b squared minus 4ac, you're just going to have the square root of 0, and that is 0. So then when I go back to that quadratic equation and plug in on the top part, negative b plus or minus this whole big thing, I end up with negative b plus or minus 0, which if you add 0, you're going to get the same thing as when you subtract 0. So I don't end up with two things. Either way, it's just negative b. That plus or minus 0 doesn't do anything, so I don't end up with two different answers. That's why I only get one. Now that last situation, b squared minus 4ac is less than 0, so a negative number, then there's no solutions. And if you're wondering, well, why is that? Now I'm back to still having something, right? Have to plus minus? Well, you can't, because then you end up having to do a square root of a negative number. You can't take a square root of a negative number. It has to be positive or 0. So in that case, there will be no solutions. And what that looks like on a graph is a parabola that just never gets to the x-axis. If the vertex, let's say, is at 2, and the parabola is pointed up, it just never gets there. This is what would happen if you were to try and solve that with the quadratic formula. You would get a negative number under the square root. So this is the most important part for if you're not going to use a calculator, because they might give it to you just as a generic b squared minus 4ac is greater than 0. How many solutions are there going to be? There's nothing for you to plug into your equation there, or your formula, or your calculator. You just have to understand, what does that even mean? How does that give me anything with a number of solutions? This is what you're looking for. Just, is it positive, negative, or is it 0? So now, like I said, you can use your calculator to solve quadratic equations if you have the right kind. So to do that, quick little tip, I would recommend you just specifically look up how to use the 0 function on your specific calculator. Or more generically, just look up how to solve for x-intercepts with your calculator, because it might use a different term for that function. Different calculators do it different ways. I don't know all of them, if I'm being totally honest. I only know the few I've worked with. So I am going to walk through it for the most common type of calculators that I have seen, but yours might be different. So first, always make sure that your calculator is allowed in the ACT. Check their website. But then look up, how do I do this for my calculator? But let's go into it for a lot of the models of calculators that I've worked with. First of all, get your quadratic equation in the correct form. So set it equal to 0 or set it equal to y, and then have everything else by itself, if it's not already like that. Then we can get to your calculator. So you're going to want to press the y equals button, or wherever you type in whatever equation that you want to graph, and enter your equation. Then press second and then trace. So that is going to give you the calc menu. If you look above the trace button, you're going to see the word calc. Second means you're just going to go to the thing right above it. That's what you're doing here, is going to the calc menu. In there, the second option is going to say 0. So you can either go down to 0 and press enter, or you can just press 2 to pick the second option. This will then pull up the graph of your equation, and there's going to be a little cursor for you to move around, and at the bottom of the screen, it's going to read left bound. So it's just looking for you to take that arrow key and move that cursor anywhere to the left of whatever x-intercept you see on that graph. You might have to do this a few times, one for each x-intercept. So pick one, move the cursor to the left of that x-intercept and just press enter. Then the bottom of the screen is going to switch from left bound to right bound, and it just wants you to pick any point to the right of that x-intercept. Now, for any of these to just be kind of close to it, you don't want to go to the left of the left intercept and to the right of the right intercept, because then there's going to be two things in between them. You're just trying to bracket one of them by close by. So use the arrow keys to get just to the right of whatever x-intercept you want, and press enter. At that point, that bottom of the screen is going to switch from left and right bound to just say guess. You can actually just ignore this for simple graphs like the ACT. That's for more complicated types of things that you're not going to have to worry about. What they technically want you to do is move the cursor as close to the x-intercept as you can, but it's not necessary at all. So you can just ignore it and press enter again. At that point, it will give you the answer for that x-intercept that you just bracketed. And at the bottom, you're going to get the x value and the y value, and that's going to be your answer for one of the intercepts. You then have to do this all again for each x-intercept that you see. If it's a quadratic equation, you're only going to see 1, 2, or 0. And that's going to do it for today. Hope it was helpful. I'll see you on the next one.